Hey guys, I hope you guys are doing good today and welcome to the today's video. So today we are going to talk about something on WebAssembly. So WebAssembly is one of the most important technology which is getting emerging very badly, and it will overcome the Docker as well. And some people says like going to be a comparison of Docker versus WebAssembly. So WebAssembly has a lot of benefits, a lot of things it needs to learn. So we will talk about at the high level view of what is WebAssembly, how it can be used, and what are all the challenges with WebAssembly. So without wasting any time, just get into the video. Okay, so what is WebAssembly? So WebAssembly is a binary instruction format for stack-based virtual machines. So WebAssembly is designed as a portable compilation target for programming languages and enabling a deployment on the web for client and server applications. So there are certain features of WebAssembly. WebAssembly is portable, fast, and safe. So it is portable. So why we call as a portable? So WebAssembly code can run on any web browser. So it runs along with the static programming languages, basically HTML, JS, JavaScripts, CSS, and all those things, right? So it supports it basically, and regardless of underlying an operating system or any hardware. So it runs on any operating system like Windows, Linux, Ubuntu, CentOS, anything, and regardless of any firmware upgrades of hardware. Okay, so it is very fast. It code can run at near native speed, and thanks to the use of stack based virtual machines actually, and it is safe. It's a sandboxed, so it cannot access the host system or any other web pages. So WebAssembly is supported by all major web browsers, including Chrome, Firefox, Edge, Safari. So it is also supported by some server-side platforms such as Node.js and Dino and all those things. So WebAssembly is powerful tool that can be used to build a wide variety of web applications. So it can be used to compile code written in a languages such as C, C++, Python, Go, Rust, and all those things. It can also used to create a web-based programming language at the static layer. You mean to say at the web browser layer. Okay. So WebAssembly, where it is used. So it's used in mostly on gaming space. So WebAssembly is used in build a high performance web gamings that can be a rival native desktop games, and it's used in machine learning ML space as well. Is used to run the machine learning models in a browser, making it possible to build a powerful web-based AI applications, and used in cryptocurrency layer as well, uh, with wallets and exchanging of the wallets of coins and all those things in the browser layer. So it's WebAssembly modules such as can be used to share a code between the different web pages as well, and make it possible to build a more complex and modular web applications. So it's all about the what is WebAssembly, and we will talk about what is the use cases of the WebAssembly. Okay, so the first use case, which is all about, it's completely used as a new improving a performance, enabling a new features, making a web applications a more secure, improving a compatibility, making web development more efficient. We can go one by one now. So why it is called as improving a performance? Okay, so WebAssembly can be used to improve a performance of a web application by compiling a code to a native machine code, and this can be make a web application faster and more responsive. Okay, and it's enabling in new features. WebAssembly can used to enable a new features in web applications such as 3D graphic and virtual reality, VR space, and all those things. So making web application more secure. Okay, the WebAssembly can be used to make web applications more secure by sandboxing a code and preventing it from accessing a sensitive data. It's good, it's improving a compatibility as well. So it improves the compatibility of web application, making them work in a wider range of the devices actually. So making web development more efficient, used in a web development space for more efficient by allowing developers to use their favorite programming language to develop their web applications. So it's not depend upon only to use the Python, only to use Go, only to use Rust, only to use C++, and all those things. You can use it on any the development code, and you can compile it, and you can inject along with your static page. Okay, so it is used where? So it is used in Microsoft Edge, Chrome, Blazor, Rust, WASM, MScripten, and all those things. So Microsoft Edge is using the WebAssembly to improve the performance of the web applications, which is inside their application layer, and Chrome. uses in a Chrome as well to enable a new feature such as 3D graphics, virtual realities, and all those where. And Blazors is a web development framework that uses WebAssembly to run C Sharp code in the browser. Rust WSM, it's a project that aims to make Rust a viable, the possible language for developing web applications in WebAssembly. So MScript 10, it's a compiler that can be used to compile the code from a variety of languages, including C, C++, Rust to the WebAssembly. Okay, so these are all about the use cases. Let's talk about something on the challenges. It's very hard, right? So what are all the challenges? So challenges, it says like security is the one of the concern when they are started using the WebAssembly. It's a new technology. There are still some security concerns that needs to be addressed. For example, it is possible to create a WebAssembly module that can exploit the vulnerabilities in the web browser. So yeah, it's an issue, right? Yes, performance. It's still under development. Performance can be an issue, especially for the complex applications. Okay, tooling. This is the raised by everyone. It lack of tooling on developing and debugging the WebAssembly modules. Agreed. Okay. Ecosystem. The ecosystem is still in its early stage. There are many libraries and other resources available to use it. Adaptation. Okay. Adoption. So WebAssembly is still not widely adopted by web developers. Okay, it's agreed. Standardization. WebAssembly, it's still under the development and there is no clear roadmap for the standardizations. Interoperability. WebAssembly modules needs to be able to interoperate with other web technologies such as JavaScript and HTML. Accessibility. While accessible, the WebAssembly can improve the performance. It may also create accessibility challenges for users with old and less powerful devices. Okay, this is the ongoing issues that we have seen. Developers need to consider the performance requirement of their application and ensure that they are accessible to all users. Debugging is also becoming a challenging part here, as a traditional debugging tool may not work with the binary format. Developers may need to use a specialized tools to debuggers to identify the fix and issues on their code. Actually, limited support for the system level functionality. WebAssembly is primarily designed for web applications and may not have a same level of support for the system level functionality as a native code. This is can limit the range of application that can build using a WebAssembly. Okay, so these are all the challenges which has. I hope you might have liked this particular video, and please do subscribe it. Please do hit a like button. We'll see you on another good lecture. Thank you so much. Bye bye.